Hey everyone, today I'm going to walk you through the complete workflow of VisualLogic IDE. In this video, I'll show you how to build a complete application from scratch using AI. And I'll focus on demonstrating the core feature of VisualLogic, which is the bidirectional mapping between code and visual representation. So let's get started. First, we can go directly to our online editor at editor.visuallogic.ai. When you first enter, you'll be prompted to register and log in. Let's click here to sign up, and we can use Google for a quick login. Just select your Google account and authorize the access. As you can see, after a brief moment, we've successfully logged in. Once you're logged in, this AI dialog box on the right side will automatically pop up. This is where we can configure our API key. Click on the API key configuration panel here. You can enter API keys from various model providers, and once entered, your own API key will be used directly. If you don't enter one, we'll provide a default API key, which will deduct from your account balance. After configuration, we can select an appropriate model. We recommend using Claude, as it provides the best code generation results. Once the configuration is done, we can start our project development. First, we can create a new project here, or if we don't create one manually, it will automatically create a project when we start generating. After clicking Generate Project, we can enter our requirements in this input box for what kind of application we want to build. The more specific your requirements are, the more accurate the generated application will be. If you just have a general idea, AI will interpret it and generate a project based on its understanding. Here I'm going to input a proper requirement in English. I've described a complete task management application with task list, add task, delete task, and statistics features. Now let's click on the Create App Blueprint button. This will first help us generate the planning files. When we click here, it will generate these files in sequence. First, it generates PER/JSON, which is our product requirements document that describes the overall functionality of the application. As you can see, PER/JSON has been generated. It's the requirements document that outlines all the features of our application. After PERD is generated, it will first plan out the database fields we'll need. Once the database fields are planned, it will generate our service map, JSON, which you can see is now being generated. The service map JSON defines our complete backend services, including which services are needed, data updates, deletions, and task creation. It defines all our backend services and database structure. Then the system includes task statistics, data updates, deletions, and more. It defines our complete backend services and database structure, and then it will plan our UMAP JSON. As you can see, once UMAP is generated, it creates this visual map diagram. This map shows our database, virtual tables, and the relationships between our services. It also shows how each service connects to our front-end UMAP JSON and their usage relationships. Through this map, we can clearly see what the final planned product will look like. We have a task database, virtual tables, and planned services including get tasks, get task by ID, create task, update task status, delete task, and get task statistics. It also plans which components or modules will use each service and their page relationships. So through this map, we can intuitively understand what kind of application we're planning to build. If we need to make any changes, we can directly modify these planning files at this stage, either manually or by asking AI to regenerate. If we're satisfied with this planning, we can continue to let it generate the complete application. It will generate the full project application based on these blueprint files, so let's click the button to generate the complete application. As you can see, it's sending out many tasks in parallel, including component tasks, service tasks, app tasks, and module tasks for each page. Notice that the generation is completely parallel. Whether it's front-end, back-end, or database, everything is generated in parallel. So the whole process is very fast. As you can see, in just about 10 seconds, the complete application has been generated. After generation, it imports everything into our IDE, and now the complete application is ready. After the generation, it gets imported into our IDE. Now notice the green dots next to each file. These indicate that the files have passed syntax validation and can run directly. If you see an orange dot, it means there are warnings, usually minor issues. A red dot means there are serious errors that need to be fixed before running. Currently, our entire project shows green dots, which means everything generated correctly. Let me demonstrate what happens when there's an error by intentionally breaking something. For this file, I'll cut out some content and save it. Now you can see that after my modification, it shows a series of errors. When errors occur, we can fix them using AI. Let's click Copy here and go to the AI dialog, paste the error content. Select the file that needs fixing. Now let's ask it to fix this problem. Let me send this fix request. You can see a spinning indicator appears, meaning the file is being regenerated. Once it's done regenerating, the dot turns green again, indicating the fix is complete. Now that the fix is done, let's move on to the visual editing interface. Click on the tab in the upper left corner and switch to Stage View. Here we can see all the visual elements in our stage. Let me zoom in a bit, and now we can clearly see the complete application. This is not just a simple preview, but an actual visual editing interface. We can click on any element to select it. For example, when I select this input field in the stage, you can see that it's also selected in the object tree on the right side. Whatever we select here will automatically be highlighted in the object tree. Also, we can directly select corresponding code snippets in our VL code. Through the VL code, we can see which part it corresponds to in the object tree. For example, here I'm selecting the Save Item function in our VL code. And you can see in the object tree, it automatically selects this save function. The object tree on the right shows the component hierarchy of our entire page. In VisualLogic, everything is a component, and each component contains 3 elements: properties, methods, and events. We can expand any component in the object tree to see its internal structure. Below is the property panel, which contains all the abstracted component properties that we can easily modify. We can easily modify any of these. It also includes corresponding events, like what logic to execute when clicked. Everything is clearly visible here, showing all the corresponding functionality. Modifying properties is actually very simple. Let me show you an example. This Save button has a default blue color. I want to change this blue Save button to green. I just need to select the button and modify its color. Here I'll change it to green and click Confirm. You can see our preview instantly updates to show the green button. And here's a really important feature: all our logic is fully visualized. For example, I click on this Cancel button, and we can see when it's clicked, it triggers this close event. Let's look at this close event. It sets the visibility property to false. And then it calls the form to reload its content. For this form reload action, we can also clearly see what it does. Reload form data. It first sets the form data to default values, then ends the action. The whole logic is very clear. This is what we call remove syntax, preserve logic. Also, all our modifications are bidirectional and synchronized. You can directly modify the VL syntax in VL Code view. When you modify the VL syntax, the VisualLogic panel also updates automatically. And when you modify the VisualLogic panel, the VL code also updates synchronously. This seamless navigation greatly accelerates our development and debugging speed. For example, in this reload task, I can click on the load content here. And you can see in the object tree on the right, it automatically navigates to this load action group. We can switch to Logic View to see what this load action does. It sets properties, sends the required data parameters through our backend service. After getting the data, it performs an assignment and finally returns from the service. As I mentioned earlier, there's a getTasks call here, which is a backend action. So we can switch to the backend, since our application has completely separated frontend and backend. Click on the tab in the upper left corner and switch to Services. In Services, you can see all our backend content, including all backend services. For example, the getTasks service we just saw, its complete logic is also very clear. It includes task statistics, filtering by conditions, and data output. Also, our database is fully visualized. Here you can see the table structure that AI generated. We can click to preview the table data and see it very intuitively. Usually, we include in our prompt a request for AI to generate some sample data. With sample data, we can see the actual effect much more clearly. Now let's preview the application and see how it looks. All operations are very simple. Let's click on Preview. As you can see, we can quickly see the result. We can switch to mobile mode to view our tasks. Since this is a mobile app example, let's switch to Mobile Preview. Notice it shows we have 4 pending tasks and 2 completed tasks. This matches exactly with the data we saw earlier. We can also add new tasks. Let me add one here. For example, a department meeting with medium priority. Some fields are optional. We can skip them, then click Create. Remember, this Create button was originally blue, but we changed it to green earlier. Let's click Create, and you can see it confirms the task was created, and in our pending list, we now have this new department meeting task. Let's mark it as complete, and now we can see it's moved to the completed list. We can also switch to the Statistics view to see how it looks. Everything is working properly. Now that our application is complete with debugging and creation, we can click on Build and Run. When you click Build and Run, you can choose your own domain or use the default domain we provide. After that, click Build, then click Next. It will generate a URL that you can access directly online. You can share this with anyone to use. Alright, let me quickly summarize today's demo. We started from scratch and used natural language to have AI automatically generate a complete application. We've seen the core features of VisualLogic. First is the bidirectional mapping between code and visual representation. Edit either side, and the other automatically syncs. Second is logic visualization, which removes syntax noise and preserves only pure logic. Third is AI-powered smart debugging, with precise fixes instead of complete regeneration. This is VisualLogic, the AI native programming foundation. Thanks for watching.